题这样的。
什么问题？
你的确很奇怪，
哪个？
然后我就看一下。写到的，下面是就，这个 asset，然后是这样子，open for element exist and open this，对。看你的 lecture 19不是这样写的，
你讲什么？
就是我看你 lecture 18的时候，你是这样写，后来 lecture 19的时候就不一样了，
讲没？
就没有一个，只有一个，好像是在哪？
啊？
没有写，这边没有写，没有写，我这边是没有写的。
然后你讲哪里不一样？
就你讲是 open disk 的话，在里面也就是 open disk，但是你画的是这个图，
没有，你讲什么东西不一样？
现在就是你的 lecture 19跟 lecture 18不一样。
哪里不一样？
但是你的 lecture 19应该是
有没有
写那个
错东西？
open disk，open set 啊，open set，有一个是 core open，是 core open，disk 啊，就没有写 open disk。
我修是上面下来哦，我修是上面下来，就是说我这 notation 是 for open disk，它是连下来。
所以是一样的。
嗯
一样OK。
，OK，
那为什么这个都是一个圈圈，不是那种
你讲dot 哈，
啊？
你讲dot 哈，
为什么是一个完整的圈？
可以，应该要dot，
呃，
图上面应该要dot。看一下我在画什么，这个是去年的，要切，要dot，我改一下，
有其他的，应该还有其他的。那个 proof 啊就是你讲那个，为什么一定要是一个 triangle 在，一个 rectangle 在里面？为啥？
因为这一个给你一个圆形，不，这个给你一个四方形，
为什么不可以是一个圆形
这个
啊？
这个，
对，为什么不可以？不是，我不是讲这个定义，
嗯
就是讲为什么
嗯
P
嗯，
我可以写一个圆形啊？我这个 boundary point
怎么呢？
为什么不可以？
没有，我是根据这两个定义，这个给你四方，这个给你 rectangle，这个给你 circle。
对，那你的 P 是这样子的，你 P 是放在一个
哦，
rectangle
随便哦，都可以。
都可以。
I mean，我也可以画我如果就随便的话就来普通的。
嗯，
我只是想说的是，如果我可以帮这个 P 摆一个四方形，我也可以帮它摆一个圆形。如果我帮它摆一个圆形，我也可以帮它摆一个四方形。这是我的 point，这是我的 point。
像你的 proof 都，你的这个的 proof，你这个的 proof 是我在 SY coding 吗？
什么意思啊？什么意思？
就是你要 proof 这两个是相等，然后
啊
你是在 SY coding 那上面的，不是？
对对对对对，
为什么我要把它移到中心？这样不是要舍弃一些部分，然后又引进那些新？
没有啊，
没有没，
没有
把它放到中心啊。哦，
没有，因为我这个 ball 可以在任意一个 center 都可以，这个 dis 在什么 center 都可以。但是这一个东西一定会，这个也是可以不在 center 的，but 嗯，
那为什么我们一定要好像在线的比较好做？
什么哪一个？
这个
没有，都不在，
从这边
都不一定在 center，都不一定在 center 呀，都不一定在 center，都不一定，因为这个可以 negative 或者 negative positive 就在不同的 quadrant 里面。
因为如果你把它放在 center 的话，跟它放在另外一边不是不一样吗？
什么意思？
就是如果你放在中心的话，就是以中心为主，然后扩散嘛，扩散，然后一些 point 都，
然后，
但是如果你放在另外一边的话，它就不是这个的 point 了。
但是不用紧啊，我只要帮助他就好了。我没有说要我的里面只有他，不可能，不一定的嘛。我是说，
里面只有它。
就我不一定，你看我这个也是有多过的点在，不是 P 里面的点也有在里面。
我可以不可以把它理解成，就是我把这个 radius 可以一直放大，一直放大，然后就跟就也不一样。
你不可以无限放大，你有一个 finitely 的 bound 嘛，get 到？
嗯，
你只要能够找到一个四方形或者一个长方形或者一个 this 包住啊，就是包的被包住了就好了，管你怎么包，你用很大的东西去包，可能你的东西袋这个很小，但是你用一个很大的纸袋去包它，它也是包住。
但是也是有一些 point 嘛，不是吗？
什么包这样？
比如讲，如果你是一个人，你 radius 是00，然后你的不是零，你的 center 是00，然后你的 radius 是1，然后你就会找到所有那些关于到就是符合这个 disk 里面的那个 point，
然后
然后你再放大它就会拿到更多其他的，
什么问题？
这样就不这样子的话，
但是你用一个大纸袋、小纸袋，只要钻得到它就是包住它了。啊，管它我纸袋多
所以这是一个 point，
一个 set
一个 set。
set of point。如果它是 unbounded，这样我拿什么纸袋都装不了。如果它是 bounded，我就可以拿比它大一点的纸袋去装它。你拿更大的纸袋装它，那是你的 problem 罢了。它还是 bounded。
这里诶对，我明白，就是我这个放大或者我这个 disk 放大或放小都没有关系，只要包住这个 set 就可以了。哦，
That exists。
哦，
OK，
哦，也这样我理解错了。
你理解是什么？可以给我看一下这个东西。
啊，
你讲吗？你继续讲。
我还以为是那个 disk 是等同于那个人，我听过。
第四个 rectangular 啊，第四 rectangular
啊，我还是那个 disk 会是那个 rectangular，对吧？
不可能的，
啊，不可能，
不可能。
对对。你可以看一下你的 nature 18的。
看了，就这个图不是？你讲这个图
对对对
有问题吗？我改了。
哦，
testing 1 2 3 okay. Alright, so everyone should have submitted your project. No? Not yet. That's dangerous, huh? Not yet. Dangerous, huh? Okay. Yeah. So okay, so we have a next assignment coming out already, right? Alright. We have last project and last assignment. Okay. The assignment is out already. Okay, I give you about 3 weeks, I think. So please start early. Don't left until last day to do. Okay. So project 2 is about real life applications. Okay, of mathematics. So now it's about applied science. Okay, please listen carefully. Don't later ask me again. Okay, keep asking me. So please listen now. So for this project, you need to do 2 things. Okay, one is written, one is oral presentation. Okay, so for the first part, written assignment, what you have to do, the content page is about at least half of the A4 paper. Okay, at least. So I want to do here, you should explain a theory in a real life setting. Okay, so for example, Let's give you some example here. Okay. So for example, Apple Airport. Okay, noise cancellation. So what you can do that? You can use Fourier series. Okay, Fourier series in the sound technology. And then second, some of you did the Ramanujan summation in quantum physics, so you can talk about something like boson statistic, physics side. And soon, hopefully today, we'll learn double integral. So double integral in statistics, you can calculate high dimensional probabilities. Okay. And if you take vlog or take videos, probably you know about GoPro. So GoPro, there's a function called the hypersmooth image stabilization. Okay, so this uses the continuity in the image processing. Okay. And then if you like astronomy, you can go about finding the orbit of Mercury. Okay, this uses calculus. This is basically why Newton devised calculus. Okay, and if you like arts, you can talk about Mona Lisa. Okay, why is it so beautiful? Is there a special sequence there? Okay, talk about Fibonacci sequence. So Fibonacci sequence appear a lot in the nature, like the flower pattern, petal pattern, and so on. And the nice building in bricks. Okay. Pythagoras theorem in architecture, for example, Egypt, the pyramid. Okay. You can talk about all these. Last year, there are a few interesting projects. Maybe I can share to you. You also can look into it in the Moodle. It's around the same place. Okay, you can go into this folder here, applied version. Okay, so what sort of topic they talk about? Let's see. So Fibonacci sequence in the Parthenon in Greece. Okay, the seven wonder. I think one of the wonder. 七大什么 Seven wonder. 七大奇迹 Okay, yeah, one of them. Okay, and then Fibonacci sequence in plan. If noise cancelling, just now talk about it. Then see. This one I talk about already. Oh, this is packing optimization of canned beverage. Do you like industrial stuff? MRI, magnetic resonance imaging. Do you know what's MRI? Like you check body, you use the magnetic scan. Yeah, MRI. And then let's see. Oh, this one parametric equation in real life. So have you seen like a bicycle break in two tire, split tire bicycle? Have you guys seen that video before? Yeah, let me show you. Yeah. Let me see. Let me show you the video. Yeah, this video here. Yeah. So I come across this video and then I gave to one of the students last semester and then they calculated what happened when the both wheel move, right? So let me show you. Let me briefly show you what's they're doing. See, so they start with two parametric equation, and then when the time move, and then they stimulate to make sure that not both tire like standing together or moving together, right? So one have to be up, one have to be down. Okay. Yeah. So how you make sure? How you make sure the two tire don't move together, right? I mean they have to move out of sync to make sure you are on the ground safely. Make sense? Yeah. Yeah. If you found something interesting video or interesting article about maths, and then we can do it, compute it using calculus too. Okay. And then some of them talk about the Kepler's law, physics, and then ray tracing technology. I think this ray tracing technology is about so recently Apple put this ray tracing technology into Mac. Yeah, they use this ray tracing technology. I think mostly for gaming or video use. Yeah, this one uses vector calculus, so I haven't gone into it. But this guy do advanced, so he picked this topic here. As long as you are picking from calculus to knowledge, it's okay. And then what other interesting stuff? Brake force on a spherical submarine. Because last sem there's one happening case about submarine. You know what happened? There's one submarine disappeared in the sea, and then all of them died. So this guy, Pichon, calculated the fluid force on the spherical submarine. Also uses a double equilibrium. And then design of the gear is also about parametric equation. So how you put different gear together and then move, right? So like Big Bang, you know Big Bang, carbon zone in the UK, I think, yeah, Big Bang. How you move the big clock, right? They use a small gear to move the big gear, right? So how to put the gear in sync? You need a parametric equation. What else? Long installment. It's like using the geometry series sum. Music visualization here. You like to watch YouTube, right? Did you listen to music on YouTube? You listen to the music where the video is like there's a effect, visualing effect. So there's a moving, colorful line, right? So they use a Fourier series to do it. Discrete Fourier series. This guy also produced a file with music and then process the music and then give you the effect. He do the coding. Okay. This is a divine structure of the human and body. This is like the Da Vinci Code. You know the Da Vinci Code, the famous picture. Yeah, talk about the Fibonacci sequence. What happened? Body. What's the perfect golden ratio of body? When you talk about golden ratio, then you can talk about Fibonacci sequence. This one analyzing the energy consumption in building. So he took I'm not sure you heard the story about the SMUM case or not about the electricity bill. There's an electricity bill on the over 1,000, but apparently they calculated wrong, but yeah, caused some issues. So this guy talked about how to calculate the electricity. Yeah, so he showed this bill. You all have to receive this bill every month or not? Same bill. So he showed this bill there for 1,400. But apparently this is the wrong calculation. So there's a complaint last time. The school electricity bill gone too high. So use some multiple integral to compute all the affecting factors. Okay, calculating how much you should get for each week. I mean for each month for your electricity bill. Okay, yeah, they do the calculation here. And then what else? If you like music, there's some geometric series in the music. How you define the octave, do, re, mi, fa, sol, la, ti, do. How you define the frequency. Okay, for do, for re, for mi, for fa, for sol. Okay, so they use the geometric series. Continuous compound interest, if you are favor in banking, finance stuff. Adjust the structure of the portfolio to reduce risk. And then so yeah, you can have a look if you like. There's a project by the previous student. Okay, yeah. And actually there's one category I forgot to put here. Actually it's sport. And I saw that in your class quite a lot of you like sports, right? For example, Seng, right? Seng, do you like sports? Let me see. Let me go back to this file first. Yeah, you can talk about sport. Why when you play like this, the ball will like go straight, go far, or go away, right? You can talk about these tangential direction of your racket, for example. Yeah, why your ball will be out, why your ball in, how you smash, how you make sure your smash is making the ball going into the court rather than outside the court. Okay, right. That's like few rotational movement you have to do before you strike the shuttle or the ping pong. You can talk about that. The thing that you like, the thing that you everyday practice. What are you doing actually? Right. Well, so you have to rotate here. You have to rotate here. And then you have to measure your face of your racket facing where? Facing up, facing down. And then what's the moment you hit the ball? Ah, here. Okay. Yeah, similar to badminton. It's the same. And then you can talk about sport also. Yeah. Okay. And that's one thing. That's one thing actually I suggest them, but nobody do it. Finally, in the end, there's one Chinese trick. So they turn the umbrella, right? They turn the umbrella. Use the leg or body, any part of the body to balance the umbrella. Have you guys seen the trick? No, never seen. Huh? Wait. Must show you guys. Like Chun Wan or what they will have those performance. Do you guys know? Like imagine this is an umbrella, then they like can turn like this, and can they use the leg to balance it, right? So you can use double integral to compute where's the center of the mass, right? Make sure you don't drop it. Okay, you need to control the center of it. Okay, yeah. Fanya, do you know what am I talking about? You never see like an umbrella? Yeah. Huh? You don't know? It's a stunt. Okay, 杂技表演 is a stunt. No, never see. Okay, let me see if I can quickly find it or not. Yeah, something like this. See? Yeah, this is also balancing stand here. Yeah. See how they keep the center of the mass. If I give you an umbrella, you can do this or not? Maybe. So I just ask you to calculate. You don't need to do calculate. Where's the center of mass? Why they have to carry the umbrella on that side? Right? Why not the other side? Why can they do this? Why can they do that? Right? So where's the center of mass? Okay. Yeah. Also, did you see anyone that can balance with anything that they give us? Give him. If you see this kind of video before. There's one guy can balance anything that you give to him. Ever see? Ever see? No, it's like if you give him a bottle, you give him an iPad, okay, then he can just put like this and then balance it. This is also center of mass. Right? So how do you do that? With irregular shape. Right? How you balance it? Okay. Yeah, I can talk about all this. Okay. And then let's see. And then you need to present it. Oh, let me yeah. So after you do this, you need to present it. Okay, so you need to present your project in 1 minute. Okay, just 1 minute. So 1 minute by a past year experience. Okay, most probably you just need 6 slides. Almost in average 10 minutes one slide. You cannot prepare more than that. If you prepare more than that, it's very hard for you to go through all of them. Okay, about 6 slides. Okay, so you need to time yourself. Okay, practice before you present. So 1 minute for presentation. So why I give you extra 1 minute? Because there's 2 more questions you need to answer. Okay. So after you present, you need to tell me, okay, how does Max live with you? Okay, how does Max entangle with your life? So you need to tell me how does Max affect your life? Okay. And then why you first choose to study Max degree. So why you came to SMUM study Max degree. So these 2 questions you address after the project presentation. Okay, so there are 2 minutes here. And then we can probably go extra 1.5 minutes. Okay. And then we have plus Q&A section, 2.5 minutes. Okay. So everyone, you can ask each other. Okay, during this Q&A, you can ask about project stuff or other stuff. It is unclear in their presentation. So if you ask good question, okay, if you ask good question, then you will get an extra marks. Okay, for your presentation. Okay. But I wanted to say one thing. Maybe you can design your question for your friend to ask for you, but it is really clear to me whether you design the question or not. Because this is very clearly seen from last presentation. Because why? When the question is not, it's just asked finished, then the presenter quickly answer the question. They don't have time. I don't think they have time to like digest their question, but they can answer it well. Okay. So there is a subtlety there if you set your question or what. Yeah. Okay. So for this part, how to gain a high mark, you just need to be honest and sincere. I just want to see how you're performing going. Yeah, if you are sincere, if you are honest, then you'll get high mark. Okay, no. You won't get penalized much. What I want to see actually from these courses, right, where I teach, right, I want to see how hardworking you are, okay, and then how creative you are. Okay, both of these. Okay, you cannot just die hard do things, because I experienced this before. So that's why I don't want you to repeat the same thing. There's no point to do a die hard. Uh, just do things badly. You don't know what you're doing. So I need you to do it meaningfully. Okay, whatever you do, please do it meaningfully. Okay, this is how I assess you actually. This is how I assess you when I check those assignments. Okay, you need to know what you are doing. Okay, yeah. Any other question? Any question about this presentation? So the title of this presentation is Maths and Life. Maths cannot be separated with life. Yeah, can you? Yeah, okay. Okay, now seeing, you know what to do? Yeah, seeing, have to be aware for 2 weeks, for the last 2 weeks, right? So I still insist we want to do it physically because I want you to experience this kind of presenting uh, presenting experience together. Okay, so I still insist we do it together physically. So there are few choices to go about it. Either, okay, we do it earlier. Either we do it on the study week. So what do you guys think? Study week? Is it okay we do it on the study week? Or no? Okay or no? Cannot, what do you mean by too early? Sorry? Because before study week, the 2 weeks Seng will not be here. Yeah. Is it okay or not? Study week. Is everyone okay about it? Or any day on study week that you cannot do? What? Yeah. I'm not sure because some of you say you want to go back. Maybe we choose Friday like that. When you come back for exam, close to your exam day. Is it okay or not? Study week Friday. So if someone want to go back, then they come back on Friday. Is it okay? Study week Friday. Is everyone okay about it? Study week Friday. Okay. Uh, okay or not? Is everyone okay? Study week Friday. Okay. Then if you want to go back, you can go back first and then come back earlier one day, maybe 3 days. Okay. Okay. Okay, study week Friday. So we'll fix our seminar on study week Friday. You can invite your friend to come if you like. Yeah, to watch you. Okay. Or your lecturer, your favorite lecturer also can. Yeah. Then maybe I'll book a seminar room or what. I'll let you know again. And yeah. Because our number of students here is quite a few. Yeah, quite few. So I think about 2 hours to 2 hours and a half we should finish. Okay. Last semester we have like 4 hours. Yeah, super long. Okay. All right. Right. Okay. So please go through this document again. If you don't understand, approach me. Okay, approach me. And don't wait until last moment to do. Please start thinking already. Start thinking. Okay. Yeah. This is the thing you have to learn in this course. Maybe you have a problem with choosing stuff, but life is about choosing. You have to choose your own path. And you have to be responsible to the path that you choose. Yeah. Yes. Maths, I mean, everything is coming from a philosophy before, right? There's no bio, there's no chemistry, there's no physics, there's no maths, there's no. They all come from a course called the natural philosophy, and then there's spread, there's split. Okay. Yeah. Yeah, if you have any problem, just ask again. So the topics are not limited to what I say here, as long as you can find interesting topic and then relate to calculus 2, then it's fine. But first thing first, please talk to me first. Okay. Otherwise, it's hard for me to grade you. Okay. So let's return. Roshan, are you okay with the turning in report or still waiting? Still waiting. Yeah. Just after you get the report, just turn it in. It's okay. Okay. Yeah. And just now we discussed about the project presentation. Are you okay with if we do the presentation on study week Friday? Because seeing you cannot, you go back or you go back. So you, I mean, so when are you available? Thursday on the study week. You mean or study week whole week now? Oh, so you just come back for exam, is it? Oh, then should we do it earlier? Huh? Mhm. You mean during the exam week? During exam week? Huh? Then we have to do it earlier then. Okay. I mean in 2 weeks time, because there's also someone that cannot make it. Because I will still want all of you to experience together. So I want all of you to do it together physically. When are you leaving again? Sing. Where are you leaving again? 16. Then maybe we'll do it on this week. December of 11. Do a presentation on this week. Okay. So you will do presentation first and then submit project later. Project we will put into until, I guess, it is okay we put until the last week. Project 2 we can put deadline until last week. But we do the presentation first. Okay. Yeah. Sorry? Sorry? Yeah, I mean in this week. So maybe we do on which day you guys free? Give me some day. So Tuesday, Wednesday, Thursday, Friday, which day? You guys the most free? Friday. Which day you guys free on this week? Most free. Huh? What do you mean by huh? Whole week not free? How come? Or you have orientation on this week? What do you mean this Saturday, Sunday? But this one is December. Yeah, December 11. The week on December 11. Sure, I mean this week, the whole week. Yeah, that's what I meant. So, are you coming back to study? Yeah, right. Yeah. So which day? Tuesday and Friday. Tuesday and Friday. So Tuesday and Friday most free, is it? So Tuesday, what time free? Only today, only this class. Huh? So what? Yeah. Friday is morning. Friday morning. Yeah, and then Roshan aware, right? You say Monday holiday, you also aware, right? Yeah. she also aware. Yeah. Yeah. Friday morning. Okay, I will decide. So Friday morning or Thursday. Oh, but this day, because of this holiday, I have to replace my class on Friday. So this Friday I also have class. Yeah. Hmm? No, I mean this Friday I've got class from 3 to 5. So if we want, we can do 1 to 3 like that. But I will see. So let's see. Tuesday is the whole morning, is it? Whole morning free. Tuesday whole morning free. Everyone also free. You 5. 10 to 3. Wow. 10 to 3. 10 to 3. Yeah, let me think. 10 to 3.
into the presentation, you can
Ah,
once I finish your presentation, and you
yeah.
if I have read.
Okay, so either Friday, you said Friday after 11. What happened? What's your class?
Amazing. Maybe 39.
Hmm? Yeah, at the night. At the night is a choice. Yeah, night is a choice, huh? Evening is a choice, yeah. You said it could be early morning. I think
Tuesday.
yeah. Tuesday evening.
After your class.
Or after the class, 6 to 8 like that. And then go dinner. 6 to 8 and then go dinner or how? Okay or not? Cannot, too late.
好，
Huh? Too tired. 还没有回来。你几时回来？我星期三。How about Wednesday, Thursday, Friday evening? Choose one. Sorry? Which evening now? Wednesday evening now. So Thursday, Friday evening. Which evening? I mean, it would be very disturbing, I guess. Yeah, very disturbing. So Thursday, Friday evening. Thursday, Friday evening. Thursday, my class group. Thursday, Friday evening. So class until 1. So you mean you finish 1 and then 1 to 3, 3 to 5 class like that. Oh, cannot because Yan Ru coming back on Wednesday. So I do it first. Exam week.
你那个不是每次要这样的
After your exam.
Yeah， 如果我们在 before exam 的那个礼拜，在 exam 第一个礼拜。
But because someone will have different exam, I don't know. So I mean Thursday, Friday evening, okay or not? Either one of them. Yeah. Until 7. So Friday. Friday. Friday 6 to 8, no? And then after presentation we can go lunch. Conference lunch. No, sorry, dinner. Conference dinner.
No, I do conference.
Okay, no. Okay, Friday 6 to 8. Okay. So it's a December 15. Okay, 6 to 8. Then I think also easy to book room because not many classes. Okay, Friday, December 15, 6 to 8. Okay, everyone mark this date. And then you have 2 weeks to prepare your applied topic. You can talk about it first, okay? And then you write it up. You submit in the last week. Okay, last week of weeks to we'll decide again just in the last week. Okay. Yeah. Okay. The written part submit in the last week, week 15. So the talking part is week 15, 14, 13 Friday. Okay, 6 to 8. And then after conference, we can go for dinner. Okay. If you like, we can start earlier, or you guys will go class. Because my class finish at 5. If we start earlier, 5:30 or 5:30 until 7:30 like that. Then we can finish earlier. Okay or not? Okay, yeah. I finish class at 5, and then 5:30 we start this conference, and then about 7:30 we finish. You got class or you got 6? Cannot leave earlier, is it? Can leave earlier? Cannot. Yeah, maybe we do 6. Okay, let's do 6. Okay. Okay, I will make the announcement later. Yeah, you have to fix your topic first, okay, and then think about what you want to say. Okay. So how you use calculus in your real life example. So previously, what they do is they come up with the written text first, and then I check the draft, and then they make into slide. Okay, so you can roughly have your draft first, okay, and then based on that draft, you can do the slide. Okay, and then after presentation, maybe someone asks you some technical stuff or the stuff that you don't see before, you can add into your project later. Does it make sense? Yeah. Okay. Okay. So the previous practice is they have the written stuff first, and then they check it, and then they make it into slide, because we do it almost simultaneously. But now, since this is different a little bit, what you can do is you have a rough idea outline first, okay, and then make into slide, and then you write it properly, okay, into a written project. Make sense? Okay. But anyway, you need to have an outline first to help yourself, okay? Don't just think plainly. Nothing can work if you just think about it, okay? You have to write it down. Write down the outline. Okay? Okay. Okay, good. So let's recall what we have done last time. So last time we stopped at this example here, finding maximum and minimum values. Okay, it's an absolute maximum and minimum values in a closed bounded set. Okay, because we know that from the upstream value theorems, if f is continuous, okay, on the bounded closed set, okay, then you can find the absolute maximum and absolute minimum there. Okay, so this is very important. Where we found this absolute maximum and minimum, okay, this boundary here is a closed and bounded. You only found it there. It is absolute within the closed and bounded set. Okay, maybe your function can be defined on the larger set, but it is absolute, okay, and a closed and bounded set subset. Right. So this theorem just tells you that there exists. That is, you can find it, but it doesn't tell you how to find it. Okay. So how to find it? We need the critical point theorem here. Okay. if this point, okay, this FP naught here is an extreme values, means what? P naught must be a critical point. Okay, so what's the critical point? There are three types of critical point. This is similar to how you find maximum minimum in one variable. What do? You differentiate once. Check where the point equals to 0. Okay, so similar here. In here, what you do, you check the stationary point. Instead of the first derivative, you need to look for the gradient because you have more than one variable now. Okay, you need to check where's the point where the gradient equals 0. This is stationary point. Why is it called stationary point? Does anyone know? Why? Stationary means stop, right? Why stop? Why at the highest point you can stop there? At the lowest point you can stop there? Huh? The slope is 0. Okay, the slope is 0. But the most stable one is the minimum point. Because if you perturb a bit, your point will move back to the minimum point. But if you're at the maximum point, what happens? If you perturb a bit, then the object will just flow down. So this is the difference between the maximum and minimum. Okay. And then so stationary point. So let's say if you cannot cannot differentiate, cannot get the gradient, what happens? These points fall into the category of singular point. Okay, these are the points that you cannot find the gradient. So you need to check separately. Okay, you need to compute the value there and then compare which one is the largest, which one is the smallest. Okay, then other than this, you need to check the boundary point as well. Why we can check the boundary point? Because we are checking point on the closed and bounded set. Okay, there's a boundary there. Okay, let's look at the example. Return to the example. So let's find the absolute maximum and minimum values of the function fxy equals to x squared minus 2xy plus 2y on the rectangle D. Okay. So in this question, right, because we get closer and closer into vector calculus already, we are kind of doing vector calculus already, and you need some imagination. Okay, you cannot just differentiate, just integrate. Okay, otherwise you will lost in the method. So you need to try and imagine what's happening now. So this is a function, a two variable function. Okay, mapped into R. So what does this do? This tells you how a plane sitting in 3 dimensions. Okay, the R there give you the height. Okay, give you the height. So you should imagine that this is the drawing here is your domain. So you need to imagine there's an extra height axis here. Okay. Through this fxy, it tells you how the plane sitting inside 3D, 3 dimension. Okay. Okay or no? So if you plug in all these points inside this domain set here into your function, it will tells you a certain height. Okay. So for example, what? For example, if I plug 2, 0, okay, into my function, what do I get? What's the height here? If I put 0, 2 into my function, what do I get? I get 4. Okay, so the height here is 4. How about 3, 2? 3, 2. 9 minus 12 plus 4, which is 1. So here is the height 1. Okay, for example. And then 0, 0, you get 0. So there's nothing here. And then 3, 0, you get 6, like this. Okay. So similarly, you can map all these points using fxy. It tells you what's the height of them. Then you can join all of them together. You can join all of them together. Okay. Is it 6? 9. Okay, thank you. 9. Okay. Yeah. Okay. Then if you form a plane up here, so where's the absolute maximum? Where's the absolute minimum? Okay, this is the question that we want to address now. Okay. Yeah. All right. So last time we computed what's the stationary point by computing where
the gradient equal to 0. It is at 1, 1. Okay, at 1, 1, what is f? F is just the value of f is 1. Okay, at 1, 1. And then next, 2 more points we need to check. So singular points doesn't exist because polynomials are always differentiable. Then we left with checking the boundary. Okay, we left with checking the boundary. We need to check what's the values on the boundary. So here, the boundary here is what? It consists of 4 lines. Okay, 4 sides of the rectangle here. L1, L2, and L3 and L4. Sorry. Yeah. Okay. Okay. So let's check one of them. Okay. One of them first. So let's check L1. Okay. So can you describe the point on L1 or not? L1 is an horizontal line. Can you describe it? How to describe L1? It's a line. So how you describe it? How do you describe it? Sorry? X equal to 3. So what does it mean by x equal to 3? So meaning all the x has coordinate 3 on x-axis, x coordinate, right? So this is actually L2, right? This one, so this L2 should be x equals to 3. Okay. So this is about L2. So L2 is s equals to 3. And then s equals to 3 is a infinite line. So you need to cut it. So where do you cut it? You cut at 0 from, sorry, y from 0 to 2. Okay. Okay, so this is L2 actually. How about what is L1? Let's return to L1 again. Y equals to 0. Okay. So y equals 0. Y equals 0 is the line, is the x-axis actually. Okay. But we need to cut it. Cut from where to where? Cut from 0 to 3. Okay. So this is the boundary line here. Okay. So how to find the maximum on this line? How to find the maximum on this line? On this line, what happened? What happened to xy? What happened to my point? They are all x0. Okay, so they are all x0 here. So my function here reduced to one variable function. So which is what? Which is x squared minus 2x times 0 plus 2 times 0, which is just x squared. Okay, so now here you see this straight line here is again a closed and bounded set. And then this is a continuous one single variable function. Okay, so again, absolute maximum and absolute minimum exists. Okay, so you need to use your knowledge from calculus 1. Find the maximum and minimum here. Okay, so how to find the maximum minimum here? Differentiate. Okay, you can differentiate. So let's differentiate it. Find the stationary point. So differentiate it with respect to s. So you get 2x. Okay. Then what? Then it tells you what? Let f prime x0 equals to 0. We will get what? We'll get that. We'll get that 2x equals 0, which means that x equals to 0. Okay. So this point is either a maximum or minimum, right? So when x equals 0, what is y? So our y is fixed already. So this is the point xy equals to 0, 0. Okay. Along this L1, our y is always 0. Okay. So how we decide whether this is a maximum or minimum? Second derivative. Okay, let's do second derivative here. So this second derivative is 2. 2 is greater than 0. So that means this point is a minimum point. Okay. Minimum point on the line. So let me write down. So xy equals to 0, 0 is a minimum point on L1. Okay, just on L1, along L1. But after checking stationary point, we need to check what? We still need to check the boundary point. Okay, because this function is differentiable. So what's the other boundary we haven't checked? So this is a line, right? What's the boundary of a line again? It's just 2 dot. Okay, it's just 2 dot. So for this is the endpoint, the two endpoints here, 0, 0, and 3, 0. Okay, but 0, 0 we already identify as a minimum point. So we need to check the 3, 0. What's the value of 3, 0? Okay, so what's the value of 3, 0? So value of 3. Okay, so the value of 3, 0 is 9. Okay, so you sub 3, 0 into your function formula. So how do you decide this is the maximum or minimum? So you actually need to know what happened for x squared along this line here. You know what happened along this line? Okay. So what's the graph you need to draw here? SZ, correct. So you need to draw the XZ graph here. Okay. So your S square looks like this. Okay, but the domain you look at is just 0, 0 to 3, 0. And then you compute that 3, 0 is actually 9. Okay, or I just throw away the y coordinate. Okay, so you can see that 3, 0 actually is a maximum here. Then you see that this function is increasing here. Okay, so along this path on the z extra z axis, this plane is increasing. Okay, so actually, right, you can really not need to go through this step here, because you can just see it from the graph here. Okay, so if you know the graph, it is easy to see where is the minimum, where is the maximum here. Okay or not? Okay, so if you already know about the graph, you don't need to go through this first derivative, second derivative test, right? Because you see this step is like kind of long. But once I get the graph up, you can easily see which one is the maximum, which one is the minimum. Okay, no. So the first thing first, if you know how to draw it, then you can straight away check which one is maximum. Okay, no. Okay. Okay, so let's write it down. So here, this is the largest point. So our smallest point here is at the F00. Okay, equals to 0. Okay. Is it F00 is 0, right? Yeah. Okay. So there are 2 points to compare here. Any question about this line here? If not, right, let you try the other 3 line. Again, I give you about 5 minutes. Try the other 3 line. Okay. Yeah, try and compute for the other 3 line. L2, L3. Okay. And L2, I already give you how to describe this line. Okay. And then try and think about how you describe L3 and L4. Okay, so later let's get answer, one of the answer from can Zhongyi compute what is L2? Later I get answer from you. Huh? What? Refuse L2. Maybe get L3 from Zheng Tang. Okay. you do L3 first, and then L4. Can I get L4 from Roland later? Roland. Is Roland there? Roland, are you here? Can you compute L4 first? Then later we'll share answer. Okay. Okay. After we finish this example, then we'll take a break. Is Zhongyi ready or not? Huh? Okay, let's try. So L2 is a line x equals to 0. Okay. Cut from y from 0 to 2. Okay. So what happened to my fxy? What's the function we want to look at on this line? What's 9 minus 4y. Okay, so how do you find this function? At x equals to 3. Okay, so once we keep the x-axis constant, okay, then we are just left with y variable. And then we get 9 minus 4y. Okay, right. Okay, so how do you find maximum and minimum here? What's the method you use? Derivative. Huh? You can use derivative, but maybe take longer time because you need to check stationary point, you need to check boundary point again. Okay, or we could just draw the graph up. Just draw the graph. Okay, let's see if I draw the graph and then get the same answer with you or not. Okay, so let's draw the graph. So what's the graph we are drawing here? So we have y-axis and the z-axis, right? Because our f value live on the x-z axis. Okay. So 9 minus 4y is what kind of graph? Minus y. Okay. And then shift up by, so it's a y equals to x graph. Okay. It's a y graph. And then you put minus y. Okay. Shift to the other side. And then you shift out by 9. So you have something like that. Something like this. 9 minus 4y. Okay. Okay, so where does your maximum and minimum occur? Tell me. Where's the largest? Where's the smallest along this curve? What's the point? Where's the point? Largest at 3, 0. How about smallest? 3, 2. Okay, so does it make sense from this picture here? So you can see that the highest point is at 0. Okay, so sorry, here's 0. And then the smallest here is 2. Okay. And then along this line, what happened? My x are just 3. Okay, that's why 3, 0, and 3, 2. Okay, does it make sense to everyone? You can use the second derivative. First derivative, and yeah, to find the stationary point. But you can see that there are 4 lines. For 4 different lines, you need to do them. Then you have a lot of extra work. If you can just reduce to this graph here, and then you can just see from the graph which one is the highest, which one is the smallest. Okay, no. Okay. In the case you cannot see this graph, then you have to use the derivative way. Okay. So fn0 is what? What do you get? f30. What's the value? Is 9. And then f32 is 1. Is it correct? Okay. Yeah. So after you do first derivative, right, you don't need to go for the second derivative test because the second derivative test only applicable on this domain here. But what we still want to compare all the points, okay, on the closed and bounded set. So you don't do second derivative test on all of them because there's no use. Because that test is just telling you that it is maximum or minimum on that line. It's not enough. We want to compare everything in the rectangle in this case. Okay, so you don't need to go until second derivative test. What you need to do, you check the stationary point. Okay, good. How about L3? So who is doing L3 again? Okay. So what's the line for L3? How you describe that line? Wait. Give the line equation first. Line equation. Why is there F? Oh, I mean, not the function on that line, but just the line itself. So this is a 2-dimensional domain, right? Okay, so you can give a line equation here. Y equals to 2. Good. But y equals to 2, remember, it's an infinite line. So you need to cut it. So where do you cut it? From 0 to 3 again. Okay, good. So what happened to my function here? So I keep my y constant. So meaning I vary my x. So it becomes a 1 variable function. So what's the function here? X minus 2 squared. Okay. So how do you find your maximum and minimum here? You draw the graph. Okay, how do you draw the graph? Okay, good. So you use the same graph before, but we shifted to the right. Because it's s minus 2 here. Okay, this tell you the shift like this. Okay, but my graph is looking from 0 to 3. So we need to know whether 0 is higher or 3 is higher here. Okay, so we need to know whether 3 is higher or 0 is higher. So what's the smallest and the largest here? What's the smallest point, the largest point here? F. What's the point? 2, 2, like this. Huh? Largest is 0, 2. Okay, smallest is 2, 2. Okay, so you need to really check whether this two, whether which one is higher before you decide. So what's this point here? This is 0, 0. Okay, so if you put F0, 0, what do you get? What happens? What do you get at F0, 0? F0, 0, you just get? What do you get? You don't get 0, right? Sorry. This is not 0, 0. This is 0, 2. Sorry. Okay. So if you put 0 into here, you get 4. Okay. But if you put 2 into here, you get 0. Okay. But when you put 3 here, what do you get? 1. Right. Is it 1? So actually this one is lower. So let me redraw this. Okay, so this is just a sketch. So you need to check your answer. Maybe move this 3 inside a bit. Okay, so this is 1. Like this. Make it continuous. Okay. Yeah. So here is the 1. So here 2, 2 is 0. 0, 2 is 4. Okay. Okay. How about next one? What's the next? Next one is L4. And let's do L4. Yeah, let's do L4. Who is L4? Roland. Okay, L4 is what line? How do you describe L4? X equals 0. Okay, good. And then S equals 0 is the infinite line. So you need to cut at 0 to 2. Okay, good. All right. So you do this. And then what's your function on that line? F of what? 0, y. Okay, you keep x constant and then you vary y. So what's your function become? 2y. Good. Okay, so 2y. 2y is a linear graph here. Okay, so how do you determine the maximum or minimum here? How do you determine? You put the value into the question. How many value you need to put? Why? How do you know that there's no maximum minimum in the middle? How do you socialize? So it turns out that in this question here, you can put 0 and 2 because this curve is linear. This curve is linear. It's linear. So let me pull out this. Okay, let me pull out this and then we'll talk. So this is a y and a z. Okay, and then from 0 to 2. Okay, what is 2y? 2y is like this. So it just happened that this curve, okay, it just happened that this curve has maximum or minimum at the endpoint. But this is not always true. This is not always true. In particular, this is what we see just now. You see? This maximum minimum doesn't occur at 0 or 3. It occurs at the middle, 2. Okay? So either you need to plot the graph to see it, or you need to use the derivative to see the stationary point. Okay or not? Okay. Okay. Okay, please take note. The maximum or minimum doesn't always have to occur at the end. In this case, you see, occur at the middle. Right? So, okay, so in this case, it is true that you just check the endpoint. So what is the smallest point? What is the largest point? You computed. Which is equal to 0. And then the other point equals to 4. Okay, good. So altogether, how many points we obtain here? So we have F11, okay, and then F22, F02, F00, F30, F30, F32, and F00, F02 again. Okay. So let's list all of them down. So we have F11. And then let's do this. 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 Okay. So we have all these points together. Okay, this one F0. Let's change. Okay, so we have all these points. So out of these points, which one is the largest and smallest? Which one is the highest? Which one is the lowest? 0 and 9. Okay, so the absolute. So right here. So the absolute. So you see, because this is absolute, right? So you need to compare all of them. Absolute maximum is at F30, which is 9. This is the absolute maximum value. How about absolute minimum value? 0, 0, and 2, 2. Okay, so you have 2 of them happening at 2 places. 0, 0, and 2, 2. Okay. Okay. So how does this picture looks like? So you go back to here. Okay. Maximum point is 30. Okay. So let's find it. So the maximum point is 30, and then the minimum point is 0, 0, and 2, 2. Okay, so you can think of it as a piece of paper get flipped out. Okay. Okay. Like this. Can everyone see this paper here? The paper on the screen? It's like something like this. But this one is higher than the other. So there's one absolute. Okay. And minimum of the others. Okay. 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 If no question, maybe we take a break. Let's take a break until 4:27.
Just to make sure you taught me to be more you say that you find specific value for MAN for visual and then go to general. Does that mean I need like more samples?
No. You need to have a general argument.
General argument. Oh, because my argument that in here is only for one photon.
Yes. So why in general it's like that?
Maybe just put one line.
Just put one line.
I mean, explain.
Explain like in general how it happened.
If you can. If not, at least you need to say that in general is wrong. You cannot just say it. Yeah.
Okay.
If you can, it's better. You can prove it if you can. Depend on how much you can do. Mm.
Ready or not? Ding. Ding 是 A. Okay. So you don't always see nice boundary, right? You don't always see nice boundary. So for example, let me give you an example here. What if I take the same shape? Okay, I take the same shape here. And let's look at this shape here. What if I take a square? Oh, sorry, a circle. Okay, let's take a circle. Okay, how are you gonna find the boundary of the circle? Okay, let's write down some circle here, right? So like this. Okay, so let's say we have f. Okay, we have f xy equals to x squared minus 2xy plus 2y. It's the same. Okay, it's the same as. Okay, how about we look at a different closed and bounded set here. Okay, in particular, we can take the closed ball. Okay, we take a closed ball. Let's take the closed ball with radius 1. Okay, so how to describe this? Anyone still remember how to describe a ball or a circle? See how to describe a circle. How do you describe a circle with radius 1, center at the origin? S squared plus y squared, then okay, equals to 1. Y is the radius. But we want to include everything inside the circle. So we need to take everything less than equals to 1. Okay, less than equal to 1. All right. So this is the ball. Okay, how about the radius? Okay, so sorry, how about the boundary? Okay, boundary of B is what? Is all the point that satisfy x squared plus y squared equals to 1. Okay. So let's say I have to check. Okay, I have to check the maximum meaning point along this boundary. How you sub the x or y value into a function. You know how to do that? Can you do it like the horizontal line, vertical line, or not? How do you find the equation for this line? Ivan? 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 It's 7 in the morning already. Okay. How to find equation, line equation for this circle? How do you substitute this point with this equation here? How to substitute this xy into your function? Sorry? Divide into 2 parts. Okay. So what 2 parts you want to divide? Y equals to square root 1 minus x squared and y equals to square root minus 1 minus x squared. So in other words, what are you doing here? You are splitting the circle into upper semicircle and the lower semicircle. Okay, so you are splitting this circle into 2 parts. Okay. Remember last time we do this? Okay, upper semicircle and lower semicircle. So this is the upper semicircle. I'll use the same color. So the upper semicircle and the lower. Then what do you do? Okay, so what do you need to do? So this x here is going from minus x minus 1 to 1. Okay, and then you need to sub your xy into your function. Okay, for example, if you sub this x and y into your function, you will get something like x squared minus 2x square root 1 minus x squared plus 2 square root 1 minus x squared. Then for this, you need to find what's the maximum, what's the minimum. Can you put this graph up on? You plot this something square with some square root multiplied by x. Can you plot this or not? If you cannot plot this, then you need to use the derivative test, the first derivative. Where's the stationary point? Okay, check the endpoint. Okay, let's compare all the boundary points. Okay, okay. Then you need to repeat the process. So I just tell you how you write down how you will get different kind of domain, and then how you work out the boundary. Okay, how you work out the boundary. Okay, so x squared plus y squared equal to y is not helpful, but if you can write y in terms of x, then this will be helpful. Okay, you can plug x and y into your function. Okay. Okay. So this means what? The maximum and minimum point here depend on x. Depend on x. Both of them depend on x. Okay, you can find an x, then you can find your y, and then you can find the maximum or minimum values. Okay. 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 Happy with this absolute maximum and minimum values? Is it okay? Okay. Okay. Next, we will introduce the second derivative test. Okay, second derivative test. Okay, so this is for checking local maximum and minimum. So it means what? So I give you a plane. Okay, I give you a plane. So you need to find where is the local maximum and local minimum. What does it mean by local maximum and local minimum again? What's the definition? Around the neighborhood, it is either the greatest point or the lowest point. Okay, so you need to find where's the plane, where's the surface, got bulge up or bulge down. OK， 在哪一个点它是凸起来的，在哪一个点它是凹下去。Okay, bulge up or bulge down. Okay, locally, okay, locally. If you want to check absolute maximum or minimum, how? You need to compare all the local maximum or minimum point. Okay. If you have boundary point, you also need to check. Okay, so theorem here. If f has a local maximum or minimum, and the first order partial derivative exists there, then the gradient must be 0. Okay, gradient at that point must be 0. Okay, if you have a local maximum or minimum, the gradient there must be 0. Meaning what? Meaning this local maximum or minimum is a critical point. Okay, it's a critical point. So you need to look for the not just critical point, it's the stationary point. Okay, it's the place where it's stationary. Okay, so you need to look for the stationary point. So after you look for the stationary point, how you decide whether this is local maximum or minimum? Okay, we need a test which is called the second derivative test. Okay, so this is a similar idea from your calculus one. What do you do in the second derivative test? Okay, if it is less than 0, it is a local maximum. If it is greater than 0, it is a local minimum. Okay, but remember, in this two variable function, how many second derivatives you can find? There are 3 or 4 combinations, right? fxx, fyy, fxy, and fyx. Okay. Okay. So you need to see how these 4 numbers tells you whether it's a local maximum or minimum. Okay, so we organize into a form which we call D. Okay, D is equal to fxx times fyy minus fxy squared. Okay, so you see, you think, hey, how this formula come from? Okay, how this formula come from? Okay, so let's think about it first. So the condition here is, suppose that fxy has continuous second partial derivative. Why have to be continuous second partial derivative? Because you need to be able to differentiate your. This means that you need to at least the first derivative is differentiable. This is what is in the know-how project. Okay. So if your second derivative is continuous, then this means that you can find your second derivative, meaning the first derivative is differentiable. So if a function is differentiable, meaning a function is also continuous. Okay. So first derivative is continuous. Okay. Okay. First derivative is continuous, and then second partial derivative is also continuous. What does this give in your project? Fxy goes to fyx. Okay. Okay. So actually, this fxy square, right, is coming from fxy times fyx. Okay. Why do I say so? Okay. We can rewrite this. We can rewrite this formula into a determinant form. Right. You see, there's a minus here. There's a suspicious minus here. Okay. Determinant will give you this minus. So how do I arrange this matrix? So I have fxx, okay, fxy, for example, yx and fyy. Okay. But since second partial derivative is continuous, fxy equals to fyx. Okay, it becomes a fxy squared. If you want to replace with fys squared, also can. It's the same. Okay. Okay, after you get this value here, okay, you get this d value here, you need to start analyze the d. Okay. So if d is greater than 0, and then fxs is greater than 0, so there are two conditions here to check, not just one. So this fss here is somehow coming from the calculus one, all right? F prime prime, okay, and you need to check d. If both of these is greater than 0, then your point is a local minimum. It's the same, greater than local minimum. And then if d is greater, but fxs is less than 0, then it is a local maximum. Okay, so f prime prime is less than 0. Okay, but the prime prime you see is the with respect to x. And then if d is less than 0, then you cannot say it is whether maximum or minimum. It is actually a saddle point. Do you know what a saddle is? Saddle. You guys know what a saddle is? Something that put on the horse when you sit on the horse. Ma'an. Again, saddle is a ma'an. So ma'an look like this. So you have one side going downward, one side going up. Yeah, no. So one side going down because you want to sit on it, right? The other side going out because you want to protect you. Okay. Yeah, so you don't go for too much. But if the horse going to throw you, you cannot control. Yeah, no. Yeah, so you can see from here. Just now we said that this local maximum or minimum should be a stationary point, right? Okay, so meaning if you put a ball on this local maximum or minimum, the ball will stay stationary. Okay, but you can see that local maximum is less stable than local minimum, because if you perturb a bit, this ball will just fall down. Okay, but how about local minimum? If you put the ball here, if you perturb a bit, then it will return to the stable. So even though both of them are stationary points, but they are still a little bit different. Okay, different by if you do perturbation. Yeah. So be careful when you stand on the high place, because you are not stable. Okay. Okay. There's another case. Greater than 0, less than 0. How about equal 0? So if it is equal 0, you know nothing. Okay, if it's 0, you know nothing. Okay. Okay. So why you can ask about question why we only see FSS, why we don't check FYY, for example. Okay, so you can prove that if D greater than 0, then FSS and FYY must have the same sign. Okay, from the determinant. Okay, they must have the same sign. Okay, so FYY will also determine whether it's local maximum or minimum. So we just pick one. just do FSS. Okay, so what's the procedure here? So the procedure here is to find local maximum or minimum, you must be at least stationary point. But you see, this theorem doesn't say if you are stationary point, then you are local maximum or minimum. It doesn't say that. Okay, so to go backward, you need to use second derivative test. Okay, so this second derivative test will tell you about the converse. When does the converse true? Okay or not? So in mathematics, is always you have a segment if then people will ask, what's the converse? Is converse always true or not? Not necessarily. If it's true, what's the condition for it to be true? Okay, so for the theorem of a local maximum minimum, for the converse of this theorem to be true, you need to have this second derivative test hold true. Okay, you need to check this the fxx. Okay or not? Okay, so let's do one example. Okay, let's find this as local extrema and the saddle point of this function here. So first thing first, if it is a local extrema, you need to make sure that you get the stationary point. Okay, you need to get the stationary point. So meaning you need to compute the gradient first. So what's the gradient here? Del f del x, what do you get? Ethan. On the spot calculation. Yeah, others also try and compute. What is del f del x? I forget how to differentiate. It partial differentiate f with respect to x. So okay, so what's gradient? Recall what's gradient? Gradient is del f del x comma del f del y. Okay, this is a vector. Okay, so what is del f del x? With respect to x, differentiate with respect to x. So what do you get? So if you partial differentiate with respect to x, right? So you need to keep your y constant. Okay. Okay, good. How about 左金? Differentiate f with respect to y. What do you get? Okay, good. Very good. So we need to set this equal to 0 and then find the stationary point. Yeah, so let's set this equal to 0. And then we will get two not linear system of equation. Okay, not linear. So what to do? Not linear. What to do? This system is not linear. You cannot use matrix already. Okay. But this is not too hard. So from 1, what can we get? Y equals to x3. Okay, make this a third equation here. So we can sub 3 into 2. Okay. So if we sub 3 into 2, what do we get? Oh, yeah, x to the 9 minus x equals to 0. So what is this? So this implies that x times x to the 8 is minus 1 equals to 0. Okay. So what kind of x satisfies this equation? X equals to 0 plus minus 1. Yeah. But if you go further in maths, right? Okay, if we can allow, for example, complex number in, okay, the degree of the polynomial is equal to the number of the root. So there actually should be 9 root you can find complex. You can find it complex. But in real, you can only see 3. The other are incomplex. This is called the fundamental theorem of algebra. Okay. All right, so these are the x you can see. So let's list them down. So 0, 1, and -1. How about the corresponding y? How do you find them? You just sub it back to equation 3. Okay, so you will get which implies x equals 0, then y equals to 0, x equals to 1, y equals to 1, x equals to -1, y equals to -1. Okay, so 0, 0, 1, 1, and -1, -1. Then you need to find your d. Okay, find d. So now you need to compute d. Okay, so need to compute d. Okay, let's compute d. So what's the formula for d? Fxx and fyy minus fxy squared. Okay, good. So what is fxx in this case here? 12x squared. Okay, how about fyy? Same. 12y squared. Okay. How about fxy? Please check others check your solution whether back sharp or not. Fxx, fly, and fxy. What do you get? -4. Okay. Others check compute. So just now we already get fx, right? So you just need to differentiate with respect to x again. Okay. And then differentiate fy with respect to y again. Okay, and then do fxy. Okay. Does it make sense? Okay. All right. So we need to check this d on 0, 0, 1, 1, and -1, -1. So let's get our d out. What is our d here? So our d here is 12x squared times 12y squared minus -4 squared, which is equal to 12. Equal to what? Just keep it there. Should we just keep it there? Okay, maybe we just expand a bit. Okay, let's expand it. 144 x squared y squared minus 16. Okay, good. So you put 0, 0, 1, 1, -1, -1 into this. Okay. So at 0, 0, your d is -16, which is less than 0. Okay. And then at 1, 1, my d becomes 128. Good. Wow, fast. 128 is greater than 0. How about -1, -1? You get the same answer because you just squared it. Okay, become 1 already. So 128 greater than 0. Okay, good. So other than d, you still need to get your fxx. What is fxx? Just now we computed is 12x squared. Okay. So at 0, 0, you just get 0. At 1, 1, you get 12. 12 is greater than 0. At -1, -1, you also get 12, which is greater than 0. Okay. So when you can conclude stuff about local maximum or minimum. So let's okay, when can you conclude? So you can conclude if your d is greater than 0 and your fxs exists. Okay, so let's check. So the first one, d is less than 0. Okay, less than 0 means what? It is a saddle point. Okay, it's a saddle point. So it is a saddle point. For 128, which is greater than 0, and fxs is greater than 0. So from the calculus one point of view, your fxs greater than 0, meaning you get a local minimum. Yes, similar to the case of -1, 1, local minimum. Okay, so there's no point is d equals 0. So there's no point that you can, it is inconclusive. Okay, so this is the picture here. It is like a pen. So this surface here is like a pen. Do you know what a pen is? pants 裤子 ，OK， 裤子啊 ，OK， but this pants has no hole here. Okay, anyway, so you see, where's the 0, 0? 0, 0 is this middle here. Okay, is the middle point here. So here is a center point. So can you see which two sides going down, which two sides going up? Okay, so in the middle here, here is going down, the other two sides going up. Okay, so this is the center point. Okay, and then at 1, 1 and -1, -1, it is a local minimum. Okay, so these two is the local minimum here. Yeah, okay, so this is a, remember this control map, level curve map here? Okay, so this circle here, there's a height here. So you can see that this height is getting lower and lower when you go into the center. Yeah, both sides is the same. And then you move up when you reach origin, and then you move further up on the other side. Okay, so you have this saddle thing. Okay or not? Okay. Any question about this? Jason, any question? Okay. Having fun with this picture? Okay. All right. Any question about this? No. Please do exercise in the textbook. Okay, please do exercise because lecture don't have too much exercise. For the next part, this we won't go through. Okay, this won't be tested. You can learn if you want because future maybe you will meet this again, but we won't test in your final. Okay, you can learn for fun. Okay, not examinable. Okay, I don't to go into this because I think of kind of useless because if you learn this if I don't tell you what is happening, it's just some calculation. You will forget for sure. You'll forget how to use it. So we won't go into this because to know about this is kind of deep, spend time. So we'll just skip this section. If you want to learn, you can. Okay, but not examinable. I will still put out the lecture note, you can learn it, but it's not examinable. Okay or not? Okay. If not, then we will take a break and then we will go into integration, level integration. We'll leave a second partial derivative. Okay. Yeah, let's take a break until 5:06.你的 project？similar to 你的 project？
那个还是关于到那个XY 还有那个 XY 的。然后你直接 plug 进去，然后讲那个圈数是不一样。
好的。
等一下，我写的很乱。
可以做一个记号，可是
我现在有写页数啊，我忘记那个。
可以做一下。
也是收钱。对。你second floor，我们有做这个，如果它底部学过，
对，
你这个东西，
对，
然后你就把它 plug 进去了。
什么问题呢？
你不是讲这样不严谨吗？如果
为什么不严谨呢？哪里不严谨？
因为它是一个 number，然后你是直接把它变成 这个会是这个会是这个，
啊，我知道你讲什么了，但是我
但是它是 XY，它是不是？
我可能知道你说什么了。如果你要这样讲的话，我就把它当成每一个点来看咯。这个 SY 是它 differentiable 的点。如果说要 precise 一点，我就 fix 它成啊、fix 它成一个点哦。但是呢，我想说的是，如果它 different，我可以把这是因为怎样讲啊？你看这个两个啊 equal on 一个点，这样它也是 equal on 所有符合这个条件的点，这样它就变成一个方向了，这就是方向来的。
哦，OK，
所以我是这样子说，就是说 app，就是说 whenever 这个 statement 是什么？
什么 statement？
你要 prove 的 statement 是什么？你不能只写 prove，你知道吗？你要写它的 statement 在哪里？你要 prove 的 statement。没有，这个不够，这只是 equation，它一定有条件的，在什么条件下这个东西才成立的？它不能够忽然无间成立的，你明白吗？要 prove statement，要 prove statement，不然的话，我的哪里能够用这个是 differentiable 呢？它一定要告诉我 f 是 differentiable，我才可以用。
有啊，有答案。
所以你要整句话，整句话在哪里？
可是我没有 proof，
怎么会离这么远呢？这两个东西？
因为我本来是打算那时候是
有
动了啊，然后你讲下个星期再讲。
明白明白。OK，哪里？对，所以你的整句话都要在。If f is a differentiable function of x y，意思是说什么 x 什么 y 它都 differentiable，所以我什么 f 什么 y 都符合这个条件，所以我就是把它看成一个 function 的 equal，所以我就 equal as function 咯。
嗯，还是一样。为什么突然就是你这个是 implicit function x 这个，然后就变成这样了？什么意思？
什么意思？什么意思？再看回去哦，再看回去，
对，
看回去，这个吗？你看 differentiable at a b，
yes，
这个 f a b 就在。
对，
differentiable at a b，f a b 也在。
这边都不一样。
这边不一样有什么问题呢？它这个 FAB 是跟着我的 definition 跑的吗？我也有这个 condition 啊，differentiable 的
这样
FAB 也要在，
对，
明白吗？
对
，OK 吗？
明白，应该没有问题，这行。
OK 啊。
Next, I go for the take part. Take part. Okay. point。所以你们现在是讲你可以买。新的，我们就一个我们那个就高里没有的，为了说没有。经济有钱请走，是9个月多。经济有钱请走，你一个人，然后你可是你不够替，可是你就是你这个是全部的运，这个不要赚钱，买的9个月。等一下，就是我们会然后我们也分一个花园。我操！我洗超正好，这那一期最漂亮。我是会好好睡觉，睡眠我。有跟过来我，这边非常平淡，对。有多高级了？说美国从随便点100米就这样。所以这会真好了，对，但是Okay, now finish discussion. Finish discussion. Okay. Okay, so what's the idea of integration? We start from primary school, okay? So let's start from primary school. Do you know how to compute the area of a rectangle? Yeah. Huh? Don't know. So how to compute an area of a rectangle? Okay. Let's say two sides here, W and M. What is the area of rectangle? What's the area of a rectangle? W times M. Okay. How about the volume of a cuboid? Yeah, what's cuboid? Yeah, some fun. Yeah, if the side is square, then it's a okay. Yeah. So let's say this side is L, W, and H. Okay. What do you get? Yeah, you get L times W times H. Okay. But life is not so easy, right? Life is not so easy. How hard? How hard could it be? Yeah, good question. How hard could it be? It could be real hard. Okay, so for example, let's say we want to find the area of a cloth. For example, right? We want to find the area of a cloth. How do you do that? Okay, the side is irregular now. How do you compute this area? Integral. Okay, integral. So you plot it on the XY plane. Okay. So you tell me what's the graph here, right? You tell me what's the graph. Then this area will become the area under the graph. But still, how to compute area of the graph? So what you do is you use a lot of rectangle. Okay, you use a lot of rectangle to approximate your graph. Okay, for example, like this. Okay, you use this. For example, you use this 3 rectangle, okay, to approximate your graph here. But you can see that there's some discrepancy, right? There's some different here. You have some extra stuff. So how do you get rid of this extra stuff? Okay. So the other rectangle you can get is a smaller rectangle. For example, you take the lower, what do you call that? Lower, upper sum and lower sum. Have you guys seen this? Upper sum and lower sum. Yeah. Okay. So you can take the upper sum triangle or the lower sum triangle. You can see that if you take the lower one, okay, you will miss out some of them. You will miss out some of them. But if you take the upper one, you will have extra. Okay. So how to find this area? You make more rectangle. Okay, so meaning you take partition of this interval here. Okay, you take partition here. So let's call this S0, and then here call it Y. So you make more and more partition. What's the advantage of making more partition here? You can make more accurate rectangle that better approximate my area under the curve. Okay, so you make more and more rectangle here. Right, for example. Okay. So for the Riemann integral, the answer will achieve when the lower sum and the upper sum have the same limit. When you take more and more rectangle, you can see that the difference here getting smaller, and smaller, approximating this. So you take limit. Okay. So you need limit to define your integral here. Okay, where you take the partition smaller and smaller. The limit you take is cutting more and more. Okay, rectangle. Okay, so let me give you this example here, this formula here. So the Riemann integral is defined like this. So if you want to integrate from A to B, an interval of fx, what do? You consider this sum here. So this fx I star is what? Is the point inside the change of x. So inside this partition, you see all the star here live in the partition. And then you take the f value on this s star. Okay. So what is this? Delta x times with a height is what? Is a rectangle. Okay. And then you take sum of them. So you sum all these rectangles together. Okay. But you can see that you will miss some of the area. And then maybe you can create more area. But when I do more star here, I get more star here. Okay, I take a limit. So you can think of this rectangle here and the delta x here getting smaller until you just take the point here. And then you just sum up all the line. So after you taking limit, you will be just summing all over the line. Okay, no? So the delta x going to 0. So this is limit. Of course, you don't evaluate delta x equals 0, but you take limit. So this is the art of calculus, you know. You don't substitute delta x to be 0, but you take limit. Then it comes out some useful number. If you put delta x equals 0 in here, you just get 0. But it changes if you take limit to 0. Okay, so this is two things. Limit to 0 and evaluate at 0 is two different things. Okay, okay or not? So once you take the limit, it becomes something useful. Okay, if you just put delta x equals 0, then you just get 0, always get 0. Okay, but somehow it turns out to be useful when you take limit. Okay, okay or not? Okay, so this is the action of a definite integral. So similarly, we have we need to generalize this to two-dimensional surface. We want to look at the area under the surface. What is area under the surface? It becomes a volume. Okay, you take a cloth and then you want to look at everything below it. It becomes a volume. Okay, it spans a three-dimensional object space. Okay. So so what's the picture here? So we will see the picture soon. So it is something like this. So you have a surface. Okay, you have a surface like this. Okay, and then you want to find the volume under the surface. So what do? So you also partition your domain, but the partition you do now is like a rectangle. Okay, you can cut in the x direction. You can also cut in the y direction. So two directions you need to cut. So it becomes what? The sum become a double sum because you need to cut two ways. Okay, it become a doubly sum. Okay, so you have this sum here. So you sum over the y coordinate and sum over the x coordinate. Okay, and then the area here become the delta here becomes what? Become a change in area. Okay, so your change in area becomes smaller and smaller and smaller. Okay or not? Okay, so you got this, something like this. It's like a staircase. Okay, so what I want to show you. So next, so this is the formula. So this is the doubly sum here. Okay, so you sum over x and y, and then you take limit for both of them going to 0. Sorry, infinity. Okay, you cut more and more and more and more. So we define the double integral of a surface, okay, dA, to be the limit of doubly sum. Okay, so that's why you learn sum first, and then you learn limit. Then we combine these two ideas together to get integral. Then we take sum, and then we take limit. Okay, so this is the definition. Okay, this is the definition. So in this course, right, as usual, definition is not very useful for computation. So we need to teach you how to compute without this. But for proving, this definition is very important. This is where you start. Okay, for proving, this is where you start. But for calculation, we will teach you some technique to calculate. Okay. So let's try. So what's the proposition here? So if my surface is always lying above xy plane, which means fxy greater or equal to 0, then it represents the volume. Okay, makes sense or not? Okay, if you look at the area under the surface, then this integral will represent the volume of the solid under the surface and above rectangular arm. Okay, let's try this example here. So let's look at this surface here. Square root 1 minus x squared. Okay, you want to integrate over a fixed domain, which is -1, 1, and time -2, 2. Okay. By interpreting the double integral as a volume. Okay. So first thing first. So which one we want to determine first? So let's determine this function is greater or equal to 0 first. Okay. So fxy let fxy equals to square root 1 minus x squared. Okay. So is this function greater or equal to 0 or not? This is a square root function, right? Square root function must be greater or equal to 0. Okay. So this means by this proposition here, okay, the double integral here represent the volume of solid under the surface. Okay, and above the rectangle R or above the xy plane. So meaning if you want to compute this double integral here, you don't need to go and do this cutting here. Okay, you just compute the volume. So meaning we need to find the volume under this surface. What is this R? Do you know how to read this R here? What does this mean? Do you know? Anyone know? See, so first, this part is a closed interval. Okay, there are two closed intervals here. Okay, this means what? This is a bit similar to the bounded set I gave you, the definition of bounded set, but I write in terms of inequality instead of interval. They are the same. So what does this mean? This means that xy in R, okay, x is bounded between -1 and 1, y is bounded between -2 and 2. Okay, so where is this? Where is this R here? So you need to plot your domain. So your domain is x and y. So x you can take -1 to 1. Y you can take -2 to 2. Okay, so it is like a rectangle. Okay, rectangle around the origin. Okay, so this is your domain. Okay, so above this domain, you need to see what is your surface. Okay, so your surface here depend on x, doesn't depend on your y. So it only changes when you go across different x. Okay, so what happens when you go across different x? Let's say from -1 to 1. What does this surface give you? What does this surface give you? Seem familiar or not? Semi-circle. Square root 1 minus x squared. Okay. At -1, what happened? You plug the number in. 1 minus -1 squared. So you get 0. Okay. And then 1, what happened at 1? 1 minus 1 is also 0. Okay. How about the other point? Let's say we take the origin. Okay. So put into 0, you get 1. So the height is 1 at 0. And then it goes down to 0 at -1 at 1. Okay, so you need to draw, for example, the third axis. So let me try this. So draw this. So this is the third axis Z. So this number here live in Z axis. Right. So here we should get something like this. Okay. So where at the origin it is 1. Okay. And then it doesn't change across Y. So at every Y you have this semicircle. At every Y you have this semicircle. Sense? Okay. So at every Y you have this semicircle like this. So what do you get? Somehow you get like a tunnel or a barrier or the barrel cut into half. Okay. Yeah. So which is what is drawn here. Okay. So it's like this. Yeah. So what is this? So how to find the volume of this barrel here? Half of the barrel. Right? Or half the cylinder. Volume of the cylinder. How to find the volume of the cylinder? What's the volume of the cylinder? Volume of cylinder is equals to 2 pi r h. Pi r square h. Okay. Pi r square h. Right. You need to have unit cube. So r square and then times h. So pi r square h. But in this case here, there's only half of it. So half times pi r square h. Okay. So by proposition above, the double integral here is half times the volume of your cylinder, which is what? What is the radius here? What's the radius of the cylinder? 1. Okay, what's the height? Yeah, 4. Okay, height is 4. So in total, you get 2 pi. Unit cube. Or you get 2. So to use this volume method, you need to make sure your surface is greater or equal to 0. Must be above. Okay, must be above. All right. Let's try one more. Okay, let's try one more. Try one more. This one. Okay. So we have this piecewise function here. Okay, we have piecewise function cut into 3 parts. So you can see that first part, your S is going from 0 to 3. So let's draw this domain picture up. So you have 0 to 3 here. Okay, let's do it here. 0 to 3. All right. And then for Y from 0 to 1. Okay, so this is the part that you're looking at. So here I should put 1 here. So here is the first part. Sorry, let's use this. Okay, so this is the part. So on this rectangle, what do you get? You get height 1. Okay, you leave this rectangle to height 1. What's next? It's the same x, okay, same x going from 0 to x, but the y is going from 1 to 2. Okay, so you continue with your y, 1 to 2. And let's label this as 2. But you raise this rectangle to the height 2, so it's higher. Okay, 1 unit higher. And then keep going. So what's the next one? Still, x is going from 0 to 3, but your y is going from 2 to 3. Okay, so you have another rectangle, and then this rectangle get lifted up to height 3. Okay, so not that, not this end point here, not the end point here. Okay, they are not intersecting. So it's somehow not continuous anymore. Okay, it's not continuous. So in fact, this is the staircase. Okay. This is the staircase. Make sense? Does it make sense? Make sense with the staircase here? Okay. Then we want to compute the double integral. So what does this the proposition just now say? If your function is greater or equal to 0, this double integral will tell you the volume under the surface. Okay. So how do you compute volume here? How do you compute volume here for this surface? Separate into 3 parts. Okay. So which 3 parts you want to separate here? So you separate into 3 cuboid. Okay. So maybe we call them R1, R2, and R3. Okay. Because at first we know how to compute cuboid, right? Volume of cuboid. Okay. So let's get these cuboid out. R1, R equals to R union R2 equals to R3. Okay. So basically what? Basically R1 is just the first part where 0, x is less than, x is in between 0 and 3, y is in between 0 and 1. Okay. And then R2 are the xy. Okay, I have to tell you where is xy. Xy is in R2. Otherwise, we will fall into the Russell paradox. Okay. S is in between 0 and 3. Y is in between 1 and -2. 2. R3 is xy. R2. And then x is in between 0 and 3. Y is in between 1 and -3. Yeah. Mm. Mm. What did I say? Oh, yeah, correct. Right. Okay, thank you. All right, so what do I do? What do we do? So we managed to split our function, okay, the double integral of piecewise function into 3 parts. This is true in general, okay? Later we will introduce this phenomenon here. We can split the integral of piecewise function into piecewise domain, okay? Because our function, our integral is linear. Okay. And then, so for each part of this, what do we do? So actually, we'll evaluate 1 over R1, and then evaluate 2 over R2, evaluate 3 over R3. Okay, then we can use proposition on this separate 3 domain. So first one, the cuboid is height times height. Okay, your side is 3 times 1. Okay, how about the other one? 2 times 3 times 1 again, plus 3 times 1. Correct, yeah. And then altogether you get 18 unit. Okay, yeah. Straightforward. Okay. Yeah, let's see what's next. Okay or not? So remember, not always true. This is only true when your surface is greater or equal to 0. Okay. See. Okay. Okay. Go down. So when can you integrate a function? Okay. When can you integrate a function? So if f is bounded on the closed rectangle and it is continuous there, except on a finite number of smooth curves, then f is integrable. So when can f be integrable? First of all, your function need to be bounded. Otherwise, your integral, you bound an infinite volume. Okay, doesn't make sense. And then it has to be continuous, but it doesn't have to be continuous and everywhere. Okay, this is actually similar to your Riemann function, Riemann integrable in the first variable case. Okay, so if you want to integrate a function, the function must be continuous. But let's say it is not continuous at certain point. Okay, certain point. I think this point is a little bit too big, too wide. So let us put it back like this. Okay. Then your function, your integral doesn't change. Okay, it doesn't change. It doesn't change. How should you think about this? How should you think about this? Because remember, when you take the limit function, right? Okay, let me draw. When you take the limit function, when you take limit to n to infinity, the line below this function doesn't contribute much. Okay, it contributes when it forms a breadth. It forms a breadth. Okay, you have a lot of line putting together, but a single line doesn't affect the integral. Okay, so it has to be finite number. So in the two-dimensional case, this line become a smooth curve. Okay, become like a curtain. So I need to draw to you so that you know what's going on. So you go to two-dimensional case. If there's some line here, okay, let's say your surface here is not continuous. Okay, it's not continuous, meaning I need to take away some point, for example. Okay, for example, this part is not continuous. You need to remember it's just a strip. It's just a strip. Like it's just a strip, not continuous. But remember, how you estimate this strip here? You are using a cuboid. So you are using cuboid to count this area, the volume, right? But you get your cuboid smaller, and smaller to approximate this curtain. Does it make sense? Make sense or not? Makes sense. Okay. So it doesn't contribute much to your integral. Okay. So it is still integrable. Okay. And in particular, if f is continuous of r, definitely it is integrable. So before you integrate a function, you need to make sure that your function is bounded, okay, on a closed rectangle, and then it's continuous there. It might not be continuous at every point, but as set on the finite number of smooth curves is okay. Okay, property of a double integral. So what's the property here? So like what I said just now, integral operation is also linear. It's like a differential operator. You can pull the scalar out from your function, okay, all the way out to the double integral, or you can split your sum of function, okay, and then your integral respect the order on your function. So if you have a higher value on g, then your integral is bigger. Makes sense, right? Does it make sense? So if you have a higher, larger value on g than h, then the integral should be greater because it covers more volume. Make sense or not? Does it make sense? Makes sense. So this means that your integral respect the order. It might not be always true for any operator, but this one does. Yeah. Okay. So respect order is linear. Okay, you can pull scalar out, you can split the sum. Okay. All right. So we need to introduce more too. I just tell you if it is surface integral, I mean, if it is the surface is greater or equal to 0, you can find the volume. But in general, how? Okay, we need to introduce a notion here. Let's introduce a notion of partial integration. And last time you learned partial differentiation, right? So now we will learn partial integration. So what's a partial integration? Partial partial integration. Okay, partial integration. Let's say with respect to y. Okay, partial integration. So suppose that f is a function, okay, function of two variables. Okay, two variables. The function of two variables that is integrable on the rectangle. You can notice, I'm keep talking about rectangle only. Okay, because rectangle is an easy case to do. Later we will learn on integrating on different shape of domain. Okay, we will start with rectangle first. So what is inter partial integration? We will use the notation integrate from C to D, okay, of fxy dy. To means what? You want to guess or not? Do you want to guess what's this definition? You want to guess? If you want to partial integrate with respect to y, how do you integrate this expression here? You want to guess? Anyone want to guess? How to define this partial derivative integration? So you have xy here, right? But you want to integrate over y only. So how? Y equal to x. Yeah. So you just fix your x constant. Okay. So x is held fixed. Okay. And then fxy you integrate with respect to y. Okay. So this is a very common sense definition. From y equals to c to y equals to d. Okay. You integrate and then you evaluate. You can do first variable, right? One variable integration. Okay, let's try this. So after that, we define what's iterated integrals here. So you first, so for example, this first one here. So look at the bracket inside. First, you partial integrate with respect to x, and then you partial integrate with respect to y. Okay, this the second one, you partial integrate with respect to y, and then you partial integrate with respect to x. And how about I don't show you the step first? I let you try. 5 minutes. See what you can do. Then we'll check whether your intuition is correct. Compare these two figures here. What's this? Huh? You computed already? You finished computer already? How to by observation? You try first. You try first. You try first. Yeah, Seng, no, okay. What's wrong? Then go and 大便啦。
没有他的 iPad，他的那边他的那个
哦
换的那个东西，
哦
他的变掉，找不
I
到
see, I see, okay.
他的
And what?
耳机一换
S.
那换是那个他的另外一个总出来插电的会发现，然后有很多
在哪里不见？
对，在下午的，在我们认识他，他会上面，然后他的电话修他的 Apple 在一起，从昨天下午到现在一直修着，然后没有按正过那个地，
你就问问那边找。
我不知道，我不知道。你的有开到那个？
有啊，
店家对？
有的那是。
等一下，不大声。
哎，very good，终于来。Okay, what's the first one? Differentiate. Sorry, integrate with respect to x, right? Okay, so what do you get? Yeah. Yeah, take y equals to constant, so y. Oh, you mean take y outside first? Okay, okay, good. You can do that. Later, your turn. Later, thing. Okay, right? Okay, so you integrate x squared with respect to x. You get? Okay, from 1 to 2. And then you get 8 over 3 minus 1 over 3. Then you get 7 over 3 y dy. Continue. Get 7 over 6 y squared. From 0 to 3, so you get 21 over 2. Okay. Seeing. People answer, you go and play. Okay, now your turn. Do this on the spot if you haven't do. Okay, how to integrate, partial integrate x squared y with respect to y. Đấy.
Thursday 再比来。Thursday 的时候我才比来。
还要来一个小啊，
放在这里。
你到这里搞不到，这类型你不在这里。
Okay, 来，
手就好一点。
来 we do together. Okay, so we differentiate x squared y with respect to y. So we treat x as a constant. Okay, so how to integrate y now? Yeah, integrate y. What do you get? Maybe your friend helping you. What do you get? Integrate y. What do you get? Yes. Integrate y. What do you get? Yeah. Yeah. And then divide by 2. Okay, so you treat x squared as a constant. Okay, and then from 0 to 3 dx. And then you get 9x squared over 2. Okay, and then keep doing. You get 3x cubed over 2 from 1 to 2. And then it is 3 times n over 2 minus 3 over 2, which is 21 over 2.
Wow, very good effect. I want to hire you. I want to hire you too. Okay. So you see,
Like what Zheng Kang say, you get the two same answer. Okay, you get the two same answer. Why are you commute two things? Why you get the same two answer? Why? This is a bit like the carrots theorem, right? You swap fx, y, fyx, they are the same, right? Lower calculation, this one. Yeah. So you get the same answer. Why? 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 Because this is called a Fubini's theorem. Okay. What does Fubini's theorem say? So it says that if f is continuous, okay, on a rectangle, then the two different ways, order of iterated integral will coincide. Okay, it's the same. No matter you do x first, do y, or do y first, is the same. Because your f is continuous on a rectangle. This is called Fubini's theorem. Okay, so Fubini's theorem tells you that you can commute the two integrals, two iterated integral, if your function is continuous. Okay, as long as your function is continuous, you can swap your integral. We won't prove this, but the idea is this. Okay, the idea is very important for future use. You need to know what does this iterated integral means. Okay, let's say we integrate with respect to x. What happened? Okay, what happened? We are integrating over the slice of x first. Okay, we look at the change in x and then the area over this. And then we sum over y. Okay, so we sum over this piece here in the y direction. Okay, so like this. How about this, the other direction? So you slice in the zy direction first. Okay, and then you sum over the x direction. So one of them you sum in this way, the other one you sum in the other orthogonal way. Does it make sense? Make sense or not? Because for one variable integral, right, you will get an area. So if you sum up all the area, you will get a volume. Yeah, no? So the one of the partial integral, you check the area. Okay, under the curve. Okay, good. So what? So let me see. Okay, not only so this Fubini's theorem, there are two things to say here, right? Not only these two integral coincide, but they both compute the double integral, which is the limit, and the doubly limit and the doubly sum. Okay, computes that thing. So your double integral equal to both of the iterated integral you can choose. Okay. So how about applying on this function here? You can apply on this function here. So y sine xy. Okay. So is this function continuous or not? Why? Because this is a composite of continuous function. Okay, polynomial is continuous. Sine is also continuous. Okay, so how can we do this computation here? By Fubini's theorem. By Fubini's theorem, what is this integral here? Okay, so there are two directions you can choose, right? You can choose to do which one first? X first. Okay, let's do x first. So sine xy dx, you can do x first. Okay, or you can do y first. Okay, or you can do y first. You can do y first, okay? Right? So you can either do y first or you can do x first, okay? So, right. We are time out. We time's up. Yeah, 55:15. Go ahead and try. Go ahead and try which one is easier. Okay, and then let us know on Thursday. Seng say Thursday got answer, right? Okay, I want to see this answer from you on Thursday, okay? Okay, huh? Yeah, question.
How do we know which interval is for x?
This is the question we answered just now. So this is by convention. First one is x, second one is y, by convention. Okay, this is by convention. Thursday, this question, tell me how to do for both of them. Okay, there is a difference between these two. See which one is easier to separate. Okay, yeah, okay. Right. And see you on Thursday.